Hello viewers, in today's class we are going to discuss one important and conceptual problem from integrals involving greatest integer function, right? So here we have an important problem related to definite integrals, and here we have the integral from 1 to 4 and log of greatest integer of square root of x plus 1 dx is equal to alpha times log of beta, right? And we have to find the value of alpha minus beta, and here alpha and beta are real numbers, right? So what we will do, we'll first find out the integral, this given integral, and then we'll compare the result with alpha times log of beta, right? And by comparison we'll find the value of alpha and beta, and once we obtain the value of alpha and beta, we can easily find out the difference alpha minus beta, right? So let us start. Now here let us first assume this integral as I, right? So we have I is equal to 1 to 4, and we have log of greatest integer of square root of x plus 1 dx, right? Okay, so now here we'll make use of the method of substitution in integration, and we'll take square root of x plus 1 is equal to u, right? So we are introducing the variable u for the method of substitution. So we have u minus 1 is equal to square root of x, right? And now if we square both sides, we'll get u minus 1 square is equal to x, right? Okay, now if we differentiate both sides with respect to x, then we get 2 times u minus 1, and then we'll have du over dx by chain rule, and the derivative of x is 1 with respect to x, right? So du over dx is now equal to 1 over 2 times u minus 1, right? And the value of dx is now equal to 2 times u minus 1 du, right? Okay, so we have now obtained the value of dx in terms of u, right? Okay, so in the given integral we see that the limits vary from x is equal to 1 to x is equal to 4. So let us change the limits accordingly. So when x is equal to 1, then see we can find the value of u from this relation, right? So when x is 1, then u is equal to square root of 1 plus 1, and this is 1 plus 1 is equal to 2, right? And when x is equal to 4, then we have u is equal to square root of 4 plus 1, and square root of 4 is 2, so we have 2 plus 1 is equal to 3, right? So now we have changed the limits, and now we can rewrite our integral as I is equal to u varies from 2 to 3, so we have 2 to 3, and here we have log of greatest integer of u, and for dx we can write this value, right? So we have 2 times u minus 1 du, right? So now we have this integral to evaluate, so we can now write I is equal to, we can take this to outside the integral, so we have 2 times integral from 2 to 3, and we have log of greatest integer of u, and here we have u minus 1 du, right? Okay, now from the limits we see that u varies from 2 to 3, right? So when u lies between 2 and 3, because the limits of integration are from 2 to 3, right? So when u lies between 2 and 3, then by the definition of greatest integer function, the value of greatest integer of u is equal to 2, right? Because see, if we take, for example, if we take u is equal to say 2.2, then the value of greatest integer of u, that is greatest integer of 2.2 is 2, right? Similarly, if we take 2.9, u is equal to 2.9, then the value of greatest integer of 2.9 is equal to 2, right? So here we have the value of greatest integer of u is equal to 2 when u lies between 2 and 3, right? So now we can write the integral as I is equal to 2 times integral from 2 to 3, and here we have log of 2, because greatest integer of u is equal to 2, right? And here we have u minus 1 du, right? Now log of 2 is a constant, so we can take it out from the integral sign. So we have 2 times log of 2, and we have 2 to 3 and u minus 1 du, right? So now we have a very simple integral here. So I can be written as 2 log of 2, and we have the integral of u is u square over 2, and the integral of 1 du is simply u, and the limits of integration are from 2 to 3, right? So now we can write it as 2 log 2, and now let us substitute the limits here. So we have 3 square, that is 9 over 2 minus 3, and then we have 2, so 2 square is 4, so we have 4 over 2 minus 2, right? Okay, so now we can simplify it. So we have 2 log 2, and here we have 2 3s are 6, so 9 minus 6 is 3, so we have 3 over 2, and here we have 2 2s are 4, so 2 minus 2 is 0, right? So now we have 2 log 2 times 3 over 2, and this 2 and this 2 get cancelled, and we are left with 3 log 2, right? So the value of this integral is equal to 3 times log of 2, right? So viewers, the value of the given integral is equal to 3 times log of 2, and in the given problem we are given that the value of this integral is equal to alpha times log of beta, right? Now if we compare this expression with this one, then we have 3 log 2 here, I is equal to 3 log 2, so if we compare, we get alpha is equal to 3 and beta is equal to 2, right? And the required difference, that is alpha minus beta, is equal to 3 minus 2, that is equal to 1, right? So the difference alpha minus beta is equal to 1, and the value of this integral is equal to 3 times log of 2, which can also be written as log of 2 cube, right? By the property of log, that is log n log m is equal to log of m raised to n, right? So this is log of 2 cube, and this is log of 8, right? So this is how we can solve this type of problems.